Hello guys, hope you're doing well. My name is Mahmoud Kiasari and welcome to the new chapter of electric circuit. As we all know, right now we do have enough knowledge to handle the series circuit and parallel circuit. But what would happen if you do have the combination of those? Because believe it or not, very common combination of the circuits that we have in our real life is actually the combination of series and parallel. So we have to find a way in order to handle everything with them. It would be voltage, current, the power, the total resistance, and everything. So at this chapter, we are going to talk about it in detail, handle a couple of questions, and make sure that you guys completely understand it. Without further ado, let's talk about it. So at this part, as I just mentioned, we are going to combine both words together. The word that we have for the series circuits and the word that we do have as parallel right now, because as you can see, we do have a combination of all of them. So how we can somehow find an answer or find the current and voltage for all of them. So it would be this part. The very first thing that we have to know again for the review is that we do have the series circuits. It means that everything is connected side by side. It means that your total current is going to be as the same as all of the currents that you have for each component, but your voltage should be add up. Then we do have the pure parallel circuits, means that both of those connections between the elements should be have the two common nodes, so like this one, and the voltage of the source is going to be as the same as V1, V2, V3, and anything connected to that. But finally, we do have the combination of those two, and right now our job is to first of all define which of them is series and parallel, and finally we have to somehow simplify the whole thing in order to find the bigger picture, the currents and voltage and resistor, and then try to go backward in order to find everything related to each component step by step. So the application there, we do have electronic devices, we do have audio amplifiers, we do have the power supplies, we do have the computer circuits, and so many things are there, and we have to understand them in details. That's why we would start with the 6-step strategy for analysis. So the very first thing we have to do about the circuit is we have to draw the original circuit, because somehow the circuit is so complicated, it would be better to draw that based on our knowledge than try to solve it. For instance, at this point I do have the circuit that I know. After drawing, it would be something like that. The next step, it would be about identify the series and parallel sections. So as you can see over here, this section is parallel, and this section which is beside this one is going to be the series itself. Then we have to simplify the parallel sections first. Obviously we know about R2 and R3. The R total would be R2 multiplied by R3 divided by R2 plus R3. Then I do have one circuit. We can call it, I do have one resistor. We can call it as RP. RP and R1 would be in series itself. Then we have to simplify the series circuit as I just told you. After that, we have to repeat it until one equivalent resistant RT remains. Why I do need the RT? Because I would like to find the IT, or how much current goes through the whole branch. Then I have to work backward to find all of those values, because question is not done yet. I have to find the values related to voltage and current for each of these components side by side itself. So how to identify the sections? Again, for identifying them, we can see that in series indicators, or when you do have two resistance or two components in series connected to each other, they do have the same current path. It means that the I1 is going to be as the same as I2 and etc. End-to-end connection. You can see that they only have one common connection, or one leg is connection, and currents must flow through both of them. On another hand, we do have the parallel connection. As you can see, they do have two common spots, and those are connected into exact same two nodes. Then we do have the multiple current path. Unlike the last one, we do have, for instance, I3 and I4. We know for a fact that the current that gets inside should be as the same as I4 plus I3. So the good thing is we do have the same voltage across both of them. So there's a very common mistake that try not to confuse the physical layout with electrical connection. Again, wires could be like anything. It doesn't necessarily mean that they are going to lead you to the thing that I really like. By my meaning of drawing, that try to draw everything that you understand from the circuit, not try to just blindly draw everything you see. So your understanding matters. Then if your circuit is going to be a little bit confusing, even when you draw that, try to think a little bit more in detail and draw it again to simplify it by yourself. How you can simplify it? By focusing on two concepts. The very first one is series, that everything is connected end to end, and your current is going to be the same for both of, or maybe more than that, of those components. On another hand, we do have the parallel. It means that the connection would be between the same two common nodes, and you do have the same voltage itself. So let's see an action. Let's see an example that is going to help us in order to do all of those steps. So what is the mission? First of all, is that looking at the circuit. So I do have 24 volts, I do have 6 ohm, I do have 12 ohm, and I do have another 12 ohm. So as we can see over here, both of these guys are in parallel, and the combination of those is going to make me one resistor. And that specific one resistor is going to be series with this resistor. So finally, I do have my R total and I can use it. So the very first thing I have to do is find the R total. After finding the R total, based on the Ohm's law, I can find the current total or total current. Then I can find the voltage for all of them. I can find V1, V2, V3. Then after just finding the voltage, I can find the current for each of them. I do have the I total. I also can find the current for each of them, either using the normal way or you can use the current divider as we know. And finally, I can find the power dissipated in each resistor. So let's see what's going on. Again, as I told you, the very first thing you have to do is just simplify the whole thing in order to find the total resistor. As I talked about it, the R3 and R2 are going to be in parallel. And based on the very important formula that we know, R total is going to be R parallel at this point, or as RP is going to be R2 times R3 divided by R2 plus R3. So if you find that, you're finally going to have something that we call as the very first total resistance. We call it as RP, which is 6 ohm. Then, of course, we know that the 6 ohm is going to be in series with another 6 ohm. So if you add them up, you are going to have 12. And finally, 12 is going to be your total resistance. When I do have the total resistance, I can find the I total easily. So I do have 24 volts divided by R total is going to be 2 amp, and I do have my first step. So let's talk about the second step, or let's talk about the step that we have to move back for, because the question specifically asks for the voltage, current, and power inside each of those components. So let's start. I do know about the 24 volt as my some kind of voltage. I do know about so I total is 2 amp, right? So check. Then I would like to find the V1 or the voltage drop over the first resistor. It would be 2 multiplied by 6 is going to be 12 volts. Check. Then I would like to find my P or power is V times I. It's going to be what? This guy is going to be 12 times 2 is going to be 24 watts. Check. I do have everything that I need. Right now, this condition is going to be a little bit challenging. Why? Because I do have 2 resistors, and the only thing that I do have is I total itself. If you guys remember about the current divider, if I would like to find, for instance, this resistor, the good thing is that both of them are the same, right? For a fact that I know I total is going to be divided equally. But again, we are not going to only trust on that. We are going to calculate it. So my I1, if I consider this one as I1 and this guy I2, I1 would be R2 divided by R1 plus R2 multiplied by IT. What is your R2? R2 is this guy, or is R3 actually. So this guy would better to some kind of call it as I2 and I3, because indexes should be the same. I2 is R3, R2 plus R3. Cool. So R3 is going to be 12 divided by 12 plus 12 is 24 multiplied by I total. How much was that? It was 2 amp, right? So it's going to be 1 amp, right? I do have it 1. Either I can do the same concept for the next one, or I can use the KCL, because I2 plus I3 is going to be I total. I do have this guy, I do have the I total, so I can find the I3. Or I know a fact that I2 and I3 are going to be the same, because everything in each branch is the same. So again, I can find the currents, doesn't matter, I already have the voltage. How I found the voltage, it is important, guys, because at this point you see that I had 24 volts. But this side, I lost 12 volts. It means that if I would like to find the voltage over here, the only thing that I have to do is just subtract 24 by 12, the amount of voltage that I lost here. I do have 12 volts. So 12 volt would be the difference of this point and this section that we know it either as negative or the hypothetical ground. That's why I do have the 12. The good thing is that both of these guys are in parallel, right? So 12 volt of this guy is the same as 12 volt of this guy, and I have everything that I need. Either you can just look at the way that I did, it's going to be a little bit confusing, but on the left side I do have everything for you. So the very important thing that I'm telling you when you're dealing with this kind of question, and maybe you watch these videos, try to pause the video, think about it by yourself. It doesn't matter how much does it take. Try to use your pen and paper. I know these days there's so many people using just ChatGPT and try to some kind of use it, but it's somehow cheating. So try to use the pen and paper and do it by yourself, because in the final exam or any kind of exam, you don't have your ChatGPT by yourself. So it is important. Try to do it. It doesn't matter if it's right or not, but the fact that you did your effort, that matters. Then try to look at the answer sheet and try to look at this answer, and again try to do that by yourself to make sure that it's completely in your head. So let's move to the next part. Let's move to the next some kind of question. So what would happen if I do have a ladder network? It means that somehow situation is a little bit complicated, and this ladder network are very commonly designed, and the strategy is still the same, but we are going to start from the point this is farthest. What does that mean? It means that at some point you don't have only maybe one branch or two branch, maybe you have more than that. So it would be better to start from the very far branch that is completely far from your source, and then start to simplify everything by each branch, combine all of them, then move back to the thing that you could like, which is the R total. We're going to see that over here. So at this point, I do have R4, which is 20. I do have R4 is 20, R2 is 30, and R3 is 60, right? So let's start. The original circuit was this, right? So step one, I'm going to move from right to left. How I can move the right to left? You can see that 30 and 60 are in series, right? These are going to be 90 ohm. In the same time, I do have R2 and 90 ohm in parallel. On that side, I can do what? I can do some kind of so my bad, apparently something happened over here and the answer that I had was completely wrong. So let's just move back and step back to the thing that we had and try to do it by ourselves. So as I was just talking about it, R2 and R3 are going to be in series. So if you add them up, your final answer is going to be what? Is going to be 90 itself. So when I do have this 90 is going to be in parallel with 20 itself, right? So 90 in parallel with 20 would be 90 times 20 divided by 90 plus 20 is going to be 110. So if you find that your final resistance, at least for the right branch and for this branch and this branch, is going to be 16.4 is your resistance, and in order to find the total resistance, you had to add it up with what? With R1 as 10 ohms. So your final answer is going to be 26.4. So let's talk about thing that we can do right now. The very first thing we have to find, because again we have to find current that for each branch, and also we have to find a voltage for each part, right? So I total, as I just told you, is equals to V divided by RT. V right now is 60 divided by RT is 26.4 is somehow 2.3 amp. Let's use it. The V1, or the amount of voltage drop that we do have through our first resistor, is going to be R1 times I1, which is 10 times 2.3, 23 volt. For finding the I2 and IR, this current and this current, either we can use the current divider, we know about that, or let me show you another way. So we know that the voltage over here is Vx. It means that we can name it anything, doesn't matter. The voltage difference between this point and this point that we do have it as ground is Vx. How we can find it easily? This Vx is V1 subtracted by voltage drop that we have, or the V total that subtracted by the voltage drop. So Vx is going to be V total subtracted by V1. This is 60 subtracted by 23 is going to be 37. Then, in order to find this current that goes inside this branch, for example, if I call this I2 and if I call this one at I3, obviously I2 should be, I did a very wrong thing. I2 cannot be as equals to I3 because obviously they're different. But I2 can be equals to I3. By I3 means that the current that goes through this one. So let's call this guy as I4. I know that now is a little bit confusing, but stay with me. So I2 is equals to I3 because we do have a series resistor. So it would be Vx divided by R2 plus R3, right? It would be the voltage that we have divided by R total. It is 37 divided by 90, which is 0.4 amp, which is going to be my I2 or I3. What about the current that goes inside this branch? Is going to be V4, which is still the Vx. By V4 at this point is still Vx because they share the common node. So it would be 37 divided by 20 would be 1.85. So if we would like to check that our currents are right or not, we can check that I2 plus I4, if you add them up, it should be something around 2.3. But right now, if you add them up, it would be 2.25, which is still close. Again, 5 to 10% of error, that's okay. So again, sorry about the things happen. I just found it out, and I thought it would be better to record it for you to show that not all the time that you do have the right answer. You know what happened over here? At this point, I assume that the resistance that I have, 30 and 60, wasn't in series, they were in parallel. That's why if you find the parallel of 60 and 30, you do have 20, which is going to lead you to a very good number, but still it's not going to be correct. So that's why you have to be careful. It doesn't matter how many years of experience you have or how many students that you had and you thought. Sometimes you could also have the problem. That's why I'm telling you, try to double check your answer all the time. So let's talk about grouping. What does that mean by grouping? Grouping means that try to do everything step by step, modular wise. It means that instead of just looking at everything as a glance or as one unit, I'm going to look at them as a group. So at this point, you see that I do have two resistances that are sit side by side each other perfectly. I also do have another two resistance sit side by side each other perfectly. So I can say I do have group A, I do have group B. If I would like to find the equivalent resistor, which is going to be R total at this point, it would be better to find the group A total resistance, which is going to be R2 plus R3, which we know that 30. And I can find a group B, which is going to be 15, and 15 is going to be 30 again. And then I can combine these two groups together. It's going to be the combination of 30 and 30. If you combine that, it would be what? It would be 15 ohm. Right? If I do have the 15 ohm, finally, I can just add it with 10 ohm. I do have 25 ohm. Then I can find the I total. How I total would be 120 divided by 25, which is going to be 8 amp. As simple as that. As you can see over here, we just found everything that we, oh, I'm sorry, it would be 4.8 amp. Sorry, my bad. It would be 4.8 amp, which is going to be my final answer, and then I can find all of the voltage and all of the currents and etc. At this point, I'm trying to help you that how you can do it by just grouping each side at a time. So there's some kind of tool. Actually, it's not very new. We were talking about it so many times about the voltage divider of a VDR or current divider, CDR. And at a point that when you have the current and you would like to find the current in each branch and you don't have any voltage, like the previous question that we had, first of all, we found the Vx. The very simple way is that you can use the current divider. Well, one thing you have to be careful is that current divider is going to be useful most of the time when you have two resistors. When you have more than that, it's not very useful. Try to use other ways like the Vx I told you. So what was the current divider? Well, current divider says that if you would like to find the current throughout the branch that you like, your IR2 is going to be 5 amp times the resistor that you don't like, which is 4, divided by addition of them, and you have 2 amps. You can do the same thing over here as well. So another thing that we know about the voltage divider, it means that instead of just finding the current for the total branch and try to find the voltage for each of them individually, we can find them directly. VR2 would be what? Would be 10 volt times the resistance that I like, which is this guy, divided by the addition of those. It would be 7 volt, and obviously based on KVL, I know for a fact that this guy is going to share the 3 volt. Where are you going to use this kind of shortcuts in order to find a specific value fast without any kind of finding other values? To double check your answers, that would be so useful to make quick estimation that during the design that what is going on. So the bottom line, the power dissipation in each component. So we were talking about it. Every component dissipates power, usually as heat. It means that right now we do have the resistor, so every current or every power that is going to be dissipated there is going to be consumed as heat. Calculating is so crucial to ensure that you are not going to fail your component, right? So for instance, for R1, we had a formula for that. It was R1 times I1 to the power of 2. For instance, if I do have 2 amp, it would be times 6, I do have 24. For R2, we can use the V2 divided by R2. Again, this is another formula for that. For example, I do have 12. For R3, I can use this formula, and I do have this one. And finally, if you add all of them, it should give you a number, and this number should be the same if you use the total power formula as PT is equals VT times IT itself. As simple as that. So the troubleshooting flow chart, it is very important. When a thing goes wrong, how I can handle that. So the very important things that normal operation, you can calculate the expected V and I. It means that at this point we are going to compare our calculation with the thing that we have in the real life. That's why it is so important to have the calculation, to have idea that what you expect from the circuit, and then try to compare those. And if anything happened, you can troubleshoot it easily. So then you have to measure the key points like the V source, the I total, your critical nodes is going to help you to have understanding of what's going on, and you can compare the measured with the expected, and somehow you get some clue what is happening. Isolate the faulty section. That's why I'm telling you try to use grouping by grouping, because at that point you can start from the small group, then try to apply it for the bigger group, and on that point in the middle you can find some problem. And finally you can find specific failed components. So some of the common fault is that open in series section. So at this point the entire circuit or major branch goes completely dead, because as we just talking about it, one of the main issue about the series circuit. And when you do have opening in parallel branch, only that specific branch is going to stop work, but total current is going to decrease. Why? Because our total is going to increase. Finally, we do have a short circuit. Total current is going to increase dramatically. Voltage across the short drops to near zero, and this is the very dangerous situation that we have. So we talked about everything, the calculation wise, how we can have it using our measurement maybe, but right now let's talk about the real world scenario. Imagine I do have the system that's audio system. In order to control the amount of volume, I can have the variable resistance that what we will talk about it in the future is going to be volume control, and based on this volume control, the current inside each of those speakers are going to be controlled, and I do have the higher or the lower amount of volume. LED arrays. At this point, I do have some kind of switches that are going to control this. They are going to control the amount of resistance in the way. By controlling the resistance, and if I increase it or decrease it, I'm controlling the amount of current that each of those LEDs are going to have. The power distribution, as we had, is the main breaker. Is going to be serious to all of those, some kind of site or all of those sections as we were talking about, like lights, like outlets, like some kind of appliances. And I told you that these guys are completely independent. If something happened to any of them, it doesn't mean that other parts are going to fail as well. And also in electrical circuit, we just talked about it. So at this point, we were talking about the mixture of parallel and series circuit, which is very important, because as you just saw, it's common around the world that we are not only going to have one series or one parallel, we have the mixture of them. So it is very important to know the steps to do it, what things by one, then just apply all of those calculation, find the main thing, which is the R total and I total, then just move backward to find your smallest current and voltage. Also, we talked a little bit about troubleshooting and how we can have that, and I hope you guys enjoy this video. Again, try to watch the video. Sorry, something happened with some of the calculation, but I showed you that it could happen to anyone. It doesn't mean that when you have a problem, you are the only one, you don't have enough experience, but it could happen to anyone. So be very careful when you're talking about the series and parallel. So if you have any question, again, please comment me down below. I would be more than happy to help you in this journey. My name is Mahmoud Kiasari. Have a super great day, night, whatever. See you around.